Hi, this is Professor Fernandez, and in this video we're going to talk about solving quadratic equations. The examples I'm using in this video, you'll see in a minute, all come from the book Calculus Simplified that I wrote and we're using for the course. So the first example is really meant to introduce remind you, if you've already covered this, what it means to solve a quadratic equation. So this is the first equation we're going to look at here, so x squared equals 4. Now, there are a variety of ways to solve this equation. We could factor, we could express this as a, difference of squares and then factor. That's probably the preferable way. Or we could just solve it very quickly by taking the square root of both sides. So I'm going to do the fastest thing first and then show you some potential pitfalls that might happen if you are just mechanical and you apply what maybe you learned at some earlier point about solving quadratic equations. So the first thing we might want to do is take the square root of both sides. And then we would say, oh, the square root of x squared is x, and the square root of 4 is 2. Okay, if you do that, then you miss one solution, right? There is another solution other than x equals 2. And here is how we would get to it. Someone else might say, okay, yes, the square root of x squared is x. Okay, so we do end up with x on the left-hand side, but the square root of 4 is plus or minus 2. Plus or minus 2. This second method does effectively get the second solution. So not only is x equals 2 a solution, so is x equals negative 2. We can check each of those. 2 squared is 4, right? So x squared is 4, check. And negative 2 squared is 4, so x squared again equals 4, check. So these are both solutions. So this method does get us the two solutions, negative 2 and 2, to this quadratic equation. However, the devil's in the details, so to speak. So square root of 4, the way that we got to this plus or minus 2 is by saying square root of 4 is plus or minus 2. And that is actually nonsense. So at this point you might be saying, what? I've been told all my life that square root of whatever is plus or minus whatever. That's not true, right? So and not that the calculators are the arbiters of everything, but students tend to trust calculators. So if you have a graphing calculator, or if you go on the internet, go to Wolfram Alpha or any other website that graphs, and you graph the function square root of x, it looks like this. The point being that at x equals 4, there is 1 and only one y value, it is 2. So you might be wondering, how does this other negative 2 come from, and what does, why were we taught square root of 4 is plus or minus 2? So I'll answer all those questions in a minute. Hopefully what I've done now is to both intrigue you and potentially confuse you, but that means we're going to learn something new. So let me give you the third way of solving this quadratic equation that actually is the legit way, so to speak. So first of all, square root of x squared. We are solving a quadratic equation. So all possible values for x are possible, right? We have no other information in this problem that could restrict the values for x, such as only consider positive x values or only consider negative x values. Okay, so the square root of x squared is actually a new function called absolute value of x. Why does this make sense? Well, so let's think about it. The square root of 4, well, we can express 4 as 2 squared. And that, as we just talked about, square root of 4 is 2. But we could also express 4 as negative 2 squared. Okay? But negative 2 squared is still 4, right? And the square root of 4 is still 2. So if you look at these two outputs, right, and you compare them, you see that the square root of the thing that was squared ends up being just the positive part of the thing that was squared. Okay, we have a name for that. We call that the absolute value of x. So square root of 2 squared would be the absolute value of 2. That's 2. Square root of negative 2 squared would be the absolute value of negative 2. That's also 2. Okay, so that's the first thing that we learn. As usual, when you start a course in calculus, things are a bit more complicated than they used to be, but not so much so that we can't do them. This is very handy. Now we know that the square root of x squared is absolute value of x. So with that information, if I am solving x squared equals 4, I can take the square root of both sides. Let's do that. And then I now know that this is the absolute value of x. equals square root of 4. I also now know that the square root of 4 is 2. right? Not plus or minus 2. Okay, and then from here, we now have two equations. So we say if x is positive, or at least non-negative, right? Then absolute value of x equals x. Remember what the absolute value does. It gets rid of the negative sign, right? If there's no negative sign because x has no negative in it, then absolute value of x is just x, right? So I would say then absolute value of x equals 2 becomes just x equals 2. Great, that's our first solution. We found the first solution. And now here's how we find the other solution. So if x is negative, then absolute value of x, remember what it does, it gets rid of the negative sign. So to express that here, we would put negative x. This might seem a little weird, so let's do an example. Absolute value of negative 7. Well, this is the x value here. X equals negative 7. How do we get rid of the negative sign? We would multiply negative 7 times a negative 1. That would give us 7. Okay, so then this here is negative x. Again, x is negative 7. Negative x is negative 7, which is 7. Okay, so if x is negative, absolute value of x equals negative x. So we finish up with what we did up here. So then, in this case, absolute value of x equals 2 becomes negative x equals 2. And then to solve for x, we multiply by negative 1 to get our missing solution. X equals negative 2. All right, so, the first time that I encountered this eons ago, back in the dinosaur age, it took me quite a while to make sense of it all. One of the nice things about this being on YouTube is that you can rewind and you can rewatch this. And then certainly you can email me if after all that work, it makes absolutely no sense. I am more than happy to help you out with it. Since we're here, let me talk about a fourth way to solve this, which you might already know, but we will talk about a little bit later, which is through factoring. So what if I had x squared equals 4 and I wanted to solve this using factoring? Okay, so the one thing that I mentioned when you're going to use factoring to solve here, we did this in a previous, in the video right before this one. I'll scroll up a little bit in case you watch that. Right, there it is, where we started factoring these expressions, is that you can go back and write this as x squared minus 4 equals 0. Why is that helpful? Because you might recognize this as a difference of squares. X squared minus 2 squared equals 0. And we have a way of factoring differences of squares. So it factors into x minus 2 times x plus 2. This is a pretty general factoring result that is nice to know. So x squared minus a squared factors into x minus a times x plus a. Right? Doesn't matter what number a is. It could be positive, it could be negative, right? So that's a nice factoring result. And then this is probably the cleanest way to solve this quadratic equation, because now I can set this equal to 0 and I can set this equal to 0, and then I just solve for x. Here's the 2 that I kept getting, and then here's the negative 2 that I was missing from the first way of solving this problem. Okay, so that's 4 different ways of solving this. The first one of which does not give us all of the solutions. The next 3 of which do, and this middle one of square root of 4 is plus or minus 2. I would not do that. The square root of a number is positive, it's not positive and negative. The third way involves using absolute value of x. Admittedly, I think that is potentially complicated if you're keeping track of a lot of things. So factoring is probably the best way, but I wanted to show you all 4 of them and talk about that public service announcement about the square root of a number. Okay, so now let's finish up this slide talking about the next example. So I want to solve this other quadratic equation here. This one's a bit more complicated. So this is x minus 1 squared plus 1 equals 2. First thing I could do there is I can move over the 1. So I get x minus 1 squared equals 2 minus 1. That's 1. Okay. I would not recommend squaring this out, right? That's going to overcomplicate the expression on the left-hand side. Instead, I'm going to use exactly everything that we did now. So there's a, usually more than one way to do things in math, right? You could solve this as a difference of squares problem, and I will just make a note of that for us to go back later so we can review some of that. But I'm going to solve it using effectively the technique here from number 3. So I'm going to take the square root of both sides. Okay? On the right-hand side, I get square root of 1 is 1, not plus or minus 1, like we talked about. On the left-hand side, the square root of something squared is the absolute value of that something. Okay? And then from here, I get the two equations that I got before. This being itself equals 1. And then also a negative times this equals 1. All right, so that's again going back to what we talked about in this second case over here. All right, so from the first one, I can just add 1, and I get 1 plus 1, 2. And then from the second one, I get negative x. If I distribute this negative 1, negative x plus 1 equals 1. So negative x equals 0. So x equals 0. These are the two solutions that I got. It's always a good step to go back and verify that the answers you got really are solutions. It's an indication a lot of times if you end up not getting a solution when you verify this, that something went wrong along the way. Maybe you made some arithmetic error. So we have 2 and 0. So if x is 2, this would be 2 minus 1, that's 1, squared plus 1 indeed equals 2. What if we went back and did the other solution we got? What if x is 0? I would get negative 1 squared plus 1. That is 1 plus 1, which is indeed 2. Check. So indeed, we have found the solutions to this problem. So now let me finish it up by going back and showing you how to do this using the difference of squares method. So this is, again, a nice little review and maybe, again, shows difference of squares in a way you might not have seen it before. So to do that, I am going to subtract the 1 from both sides. I'm going to move over this 1 over here. Great. And then now if you squint, you can see a difference of squares. This is something squared minus 1 squared equals 0. So there's a difference of squares. And I've written blah here because I want you to focus on the fact that this is something squared, even if that something looks a little different from what we're used to seeing, like the x squared in the previous example. Okay, so that means that I can use my difference of squares result and it works just as well here. So this x minus 1 minus 1 is one of the factors, right? Put a parentheses here. And then the same thing, x minus 1 plus 1 is the other factor. If you remember how to multiply these things out, right, like the FOIL method, you could verify that if you multiply these two factors out, you do in fact get the left-hand side. All right, and then this gives us two equations to solve. This one and this one. Okay, so notice from the first one here, x minus 1 plus 1, those cancel. So this one gives me x equals 0. That's one of the solutions that we just found. This one over here, negative 1 minus 1, that's negative 2. X minus 2 equals 0, that gives me the x equals 2, the other solution that we just found. So we found the same solutions using a different technique. Might be a little more challenging in this case because, seeing this as a difference of squares may not occur to you right away. But I just wanted, again, to illustrate how you could do that in this example as well. Okay, so if we had to recap this slide, right, we've learned a lot. And again, I encourage you to go back to the video and sort of rewind and rewatch and email me if you have questions. But if I had to recap this slide, simple quadratic equation that we solved and talked about all sorts of different ways and pitfalls that could happen. More complicated quadratic equation that we solved two different ways. And then hopefully you saw a different way of applying difference of squares that you may not have seen before. So now for the last one here, this one's going to go a little faster. And the reason that it's going to go faster is that, factoring here is not going to work so well. So let's talk about this quadratic equation. So we're looking to solve 3x squared plus 14x plus 15. You can try and try and try, and factoring is not going to work, right? The factors of 3 are 3 and 1. The factors of 15 are 1 and 15, 3 and 5. So if you remember back to the video that we did about factoring, there's really no combination here of these factors that's going to help you factor this into, one linear factor and then another linear factor equals 0, right? So that's not going to work. So in this process, if factoring does not work, then what you can do is you can always do this actually, try the quadratic equation. You can always do it, but factoring sometimes a little faster. So you may remember the quadratic equation, right? If we are solving ax squared plus bx plus c equals 0, the two solutions are negative b plus or minus the square root of b squared minus 4ac, all of that divided by 2a. So then all we have to do, one of the nice things about the quadratic equation, right, which is especially nice for students, is that you can just insert things into a formula and the answer will come out. But you have to know what to insert, right? And that's why, and where to insert it. That's why I wrote this out first. So the coefficient a is the one in front of x squared. So a here is 3. So in terms of what's being written over here, I'm going to have a 3 down here for a. And then I'm also going to be subtracting 4 times 3. Okay. What else? The coefficient for b, b is the coefficient in front of x, so that's 14. So I'm looking for b in my formula, so it's over here. So negative 14 plus or minus 14 squared. Okay, and then the c coefficient is the one that does not have an x next to it. So that's plus 15, positive 15. So that's goes over here. Okay, so at this point I have written out my expression that I'm going to calculate, and I would just save you the time. At this point, this is arithmetic. So you end up getting minus 14 plus or minus 4. All of that divided by 6, which yields two solutions. Negative 5/3 if we take the positive here, and also negative 3 if we take the negative here. So therefore, this is little triangles, shorthand, mathematician shorthand for therefore, gives us x equals minus 5/3 and x equals negative 3. Okay, so those are the two solutions for this quadratic equation. All right, I promised in an earlier video that I would show you, and this is also in your reading, how you could in fact use the quadratic equation to help you factor a quadratic expression. So what if we changed the question to say factor this? All right. I tried to convince you earlier that you're not going to find a neat factorization like 3x plus 1 times, x plus 5 or something. It just doesn't work. And we see why after having solved this using the quadratic equation. Because the roots of this are not necessarily integers, right? That doesn't automatically tell you can't find a neat factorization, but it's a hint that things might not go very well in terms of factoring as you normally would. So here's how you could factor it. You could say, well, if I look at these two roots, right, I can move them over, x plus 5/3, x plus 3, okay? And if I take this, notice that if I were to multiply this out, I would have x squared plus a bunch of other stuff, okay? That is not going to give me this expression because there's a 3 in front of x squared, okay? So what if I went back and instead I multiplied these two linear factors by 3? Well, let's see what we get. So we get 3, and then let's do the multiplication. So we'll do the FOIL. We get x squared plus 3x plus 5/3 x plus 5. Okay? And then now let's multiply the 3 in. 3x squared plus 9x plus 3 times 5/3, the 3's cancel, so 5x plus 3 times 5, 15. So if I simplify here, what do I get? I get 3x squared plus 9 plus 5, 14x plus 15. There we go. That is the original quadratic expression I started off with. So is this magic? No, this is not magic, right? I will erase this here and show you a very quick summary of what I wrote in the book. If you're interested, the full details are on page 172 of the book. So if you are trying to factor ax squared plus bx plus c, that is equal to a times x minus capital A times x minus capital B, where capital A, capital B are the solutions from using the quadratic formula. Okay? So this is another nice factoring technique. When all else fails and you've tried your best to factor using the techniques that we talked about in the previous video or other techniques like factoring by grouping, for example, and you still want to factor things out, you can use the quadratic formula to solve whatever your thing you're trying to factor equals 0 to solve that, to get the two solutions, and then do the process we just did here. Move them over to create the linear factors, okay? And then multiply those linear factors by the coefficient of x squared. When you do that, you will have obtained your factorization. The expression you started off with, it will be equal to the coefficient of x squared times x minus the first solution from the quadratic equation times x minus the second solution from the quadratic equation. Okay, so this has been a video about all about solving quadratic equations in various degrees of complexity. Hope you enjoyed it, and I'll see you in the next video.